Hello everyone, welcome to my channel. In this video we will learn about the recursion tree method in the recurrence relation. So we know that in the recurrence relation we have three types of methods. So mainly three types of methods. There are number of methods, but mainly we are considering three types of methods, that is the substitution method, recursion tree method and Master's theorem method. But substitution method works only for certain type of recurrence relations like divide and conquer technique. So we can use the for the divide and conquer technique, conquer type of relations, we can't use the substitution method. Suppose here given the example here, t of n equals to 2t of root n plus log n. So for this type of examples we can substitute using the substitution method. But if this kind of recurrence relation is given, so we can't apply the substitution method, so we have to follow the recursion tree method. So like the iterative substitution method, this technique uses repeated substitution to solve a recurrence equation, but it differs from the iterative substitution method in that rather than being an algebraic approach, it is a visual approach. In using the recursion tree method, we draw a tree R where each node represents a different substitution of the recurrence equation. Thus, each node in R has a value of the argument n of the function t of n associated with it. So, for example, consider this recurrence equation here. So, t of n equals to t of n by 4 plus t of n by 2 plus n square. Okay. So here n square is the actual cost of dividing the problem into number of problems. So here the t of the problem n is divided into multiple number of problems. So we are taking the n square to this one. So we are dividing it into two halves, that is the t of, sorry, we have to consider on this n by 4 plus n by 2. So n by 4 and n by 2. So the recurrence means we are recursively applying the keeping this value in the formula given relation. Okay. So for the first step, level it takes only n square cost. Okay. So for the second step it takes 5 by 16 n square. Okay. So here the n square. Okay. So n by 4 plus n by 2. Okay, so n by 4 plus n by 2. So if you are placing this one in the given recurrence relation, so it will give the square. Okay, suppose n by 4 is placed here, then it will become n by 4 whole square and n by 2 will become n by 2 whole square. That is 5 by 16 n square. So this is the LCM of these two values, n by 4 whole square and n by 2 whole square, that is 5 by 16 n square. So this is the cost taken for dividing the problem into these two problems. So next, so we'll consider we'll again divide this problem into two problems, that is n by 16 whole square and n by 8 whole square. So after substituting the n by 4 into this one, so we are getting these values. Okay, so n by 4 into this equation. So n by 4 means n by 16, n square by 16 and n by 4 here. So n square by 8. Right? So you get this equation. So next, so the tree, the node is again divided into two parts. So if you are substituting the n by 2 into this recurrence relation, then so n by 2 in this one, so n by 8 whole square and n by 4, so n by 2 means n by 4 whole square. Right. So if you perform the LCM of all these values, n by 16 plus n by 8 plus n by 8 plus n by 4, so it will give the cost 25 by 256 n square. Okay, so we are first taking the cost here n square, we are dividing it into two halves, that is n by 4 and n by 2 whole square, and then we are substituting the n by 4 whole square into this recurrence relation, and we are obtaining these values, and n by 2 in this recurrence relation. We obtain this value. So we are just dividing the problem into subproblems and calculating the cost for the each division here, and this process will go on. So again we need to substitute this n by 16 whole square in the n by 4 and n by 2, and n by 8 whole square in n by 4 and n by 2, and this process will continue. Okay, so we are considering the, so this process will continue. So since these are all our constants, right, so theta of 1. So if you are performing the total of this total cost here in each level, so first one is n square plus 5 by 16 n square plus 25 by 256 n square, and so on. So if you are taking the common of n square here, n square into 1 plus 5 by 16 plus 25 by 256 plus so on. So that is n square into 1 plus 5 by 16 plus 5 square by 16 square, right? So 5 by 16 whole square plus, so it will be 5 by 16 whole cube and so on. If you write this next relations, if you substitute this one in the recurrence relation. So this is in the geometrics, in the format of the geometric series, right? So that is equals to n square. So the time complexity here is theta of n square. So this is in the format of a geometric series. So this is about the recursive tree method. So this is just a visual format of the substitution method, but if the problem is in the divided format, then we can apply this method easily. And Master's theorem is also there. It is like just straight away we are applying the formula here. No need to guess or no need to write this recursive tree. Just we are going to directly apply the formula. Thanks for watching my video.